Hello, can everyone see me again? Martin, are you there? Martin? I
I'm
don't
all
know
good.
what happened there. Sorry, a bit of a technical glitch.
Yeah,
The,
it's thrown out here.
yeah, no, the whole thing just stopped. It said I lost connection with the webinar server.
Okay.
Anyway, really sorry everyone for that technical glitch, but hopefully it won't happen again. Can you see my screen, Martin, just to check?
Yes, I can see your screen. I can see you.
Perfect. That's great. Yes, as I was saying, Ace have been working with WaPro since 2007. So we've got lots of interesting case studies in the UK, and Martin's going to show us some from around the world. Yeah, first of all, I'd like to remind everyone of who Ace are. Well, we've been working in water flow control and specifically mechanical engineering solutions for the water bodies for 25 years now. We've supplied WaStops, yeah, all the way from the tip of Scotland down to the bottom in Poole. Lots of different ones, different sizes on all sorts of applications. Yeah, we're the stockist of WaStop, so the exclusive WaStop partner in the UK, and we've got stock in our 400 square meter warehouse, everything up to a 600 millimeter. But of course, we don't just supply them, we can also come and install them for you, put them in, and yeah, take them on as part of an overall project. For example, we've done full turnkey pumping stations where the outfall flat valve has been put in line with a WaStop, so back to back. Of course, the WaStop protects property and people, so it fits perfectly within our portfolio of products. And you can be rest assured that we've got all the accreditations that you'd expect from a supplier come mechanical contractor. So to kick off, I thought I'd start off with a really interesting case study, which was for a 1.5 meter diameter wire stop, which we supplied down in Poole. So this particular wire stop was a perfect solution for a big timber flat valve, which was constantly silted shut. It wasn't actually silt, it was shale. Shale kept on building up against this wooden non-return valve, and literally, well, 4 to 5 times a year, they'd have to bring in an excavator to dig the shale out from the front of the flat valve in order to open it up again and allow normal discharge to continue. Now, obviously, that's not a very sustainable solution. Having to use an excavator is not a very environmental solution because, of course, you're sending an excavator to site, burning fuel doing so, but also from a cost perspective, it's very expensive. So Wessex Water and Poole Council approached Ace and said, is there anything in your portfolio that could solve this issue? We said, yeah, we've got the absolutely perfect product. You buy a WaStop, and the reason is the WaStop, it's got this pulsating flow. So it builds up a little bit more head to pop it open than it requires on a discharge. So you've got a higher opening pressure to closing. And what that means is that when it opens, it doesn't open gently like a flat valve, it bursts open. You get a complete flush of water, which can keep any material from building up. I will be honest with everyone, Poole Harbour, well, Wessex Water were a bit skeptical. They thought, well, not sure if this is going to really work. We're moving shale, you know, quite heavy material, but we've had such a problem, we give it a go. 12 months later, the excavator's not had to visit site again. It solved the problem completely, and so much so that Poole Council ordered another 6 large diameter wire stops. These are all between 12 and 1400 mil with flanges for some new outfalls that we supplied down in Halls Bay. Also, still working perfectly, very, very satisfied customer, solves a lot of problems. We don't just use them for gravity-fed outfalls. They can also be used for pumping applications. This is an example in London, Barking and Dagenham kind of area, where there's 2 Environment Agency pumping stations, Goresbrook and Beam River. Now, Goresbrook and Bream River, when they were designing it, the Environment Agency were keen to be using, particularly heavy-duty, very robust flat valves, but they wanted it completely in stainless steel. The issue that you get with stainless steel flat valves, of course, particularly in an area where theft and vandalism could be seen as an issue, is there's a lot of money hanging on the wall for a potential thief or vandal. And they were nervous, and they thought, well, how can we hide this? So we suggested the WaStop. It works perfectly well for pumped applications. So you could slide the WaStop into the pumped outfall, and therefore you've got the benefits of the non-return valve, but everything's hidden. So it's not very visible, it's not very obvious what it is, and it's not easily going to be stolen. These, I will say as well, have been installed since 2010. The Environment Agency is still using them at the moment, 10 years later. So also, proves that with a pumped application, they've still got an incredibly long life. This little video here is from the Southwest, and it's nice to show how WaStop's bespoke flanges can solve a lot of your issues where it comes with flush inverts. For example, here the pipe invert is flush with the sill, and also you can see the wing walls are very tight, so you couldn't fit a flat valve frame on here. Therefore, by supplying a WaStop which slides inside the pipe and putting a bespoke flange on the outside, it means that we could create a solution without having to completely remove the head wall and put a new head wall in. The video there gives you a sense of scale, but also showed the low closing pressure. So you'll never have too much standing water in your pipe. And having a little bit of standing water is actually a good thing in a lot of scenarios, particularly for utilities industries, where you don't want any matter drying up, because of course it starts to restrict your pipe diameter. So by keeping some standing water in there, it keeps quite a lot of the debris floating or suspended, and therefore your blockages are less likely to build up. That was a bit of a problem which they had at Walhall. So this is Thames Water. They actually started using so many WaStops off the back of this that we have a Thames Water framework for the WaStop. Thames Water on this particular application had problems where the flow in a fairly level pipe was frequently causing the debris to block up any type of non-return valve that they tried to put down in this culvert. They tried flat valves, they tried all sorts of different non-return valves, and every time it would get blocked. They were getting to the end of their tether, to the point where they thought, well, we're just going to have to put a pumping station in, and by pumping we can keep the materials moving, we can keep the flow higher, and we solve the problem. The downside of pumping, of course, is building a pumping station here. Even though it's only a small unit, they were still looking at a total cost of £250,000 roughly. So he said, before you spend that £250,000, try a WaStop. It's likely to work because it creates this flushing flow, because it's got this opening and closing pressure. It bursts open, your level drops, it closes, the level raises. It kind of works in the same kind of way as a toilet system does, in the fact that you get a lot of flow all at once, and therefore it keeps your pipe clear. They put it in at Walhall, and sure enough, that £250,000 pumping station never had to be built. I mean, think about the savings for Thames Water on that site. Really, really significant. That's also why, of course, they use them all over the place now. I mean, we've sort of supplied literally thousands to Thames Water. Welsh Water as well have started to get really on board. You can see this was an innovation award from 2016. They started to use the WaStop particularly because several properties in Wales have very flat, or as you can see from that bottom image, sometimes the pipe is actually over time has dropped or drooped in the middle. A big problem that they're seeing is because everyone's trying to conserve water and save water, which is a good thing. People are putting items, quite often the bags that the utility companies issue, which are full of sand or some kind of material which absorbs water, to reduce the overall capacity in the system. and therefore your flush is less. Now, what happens is when your flush from the toilet systems is less, obviously the flow passing through the pipe is less, and when you've got pipes that are curved, material starts to settle in the bottom, and that eventually causes blockages. There are a bunch of other applications, but that was one key one. So by using the WaStop and having that opening closing pressure, it means you're maintaining that flow rate when you need it to flush the material. So it builds up a head of water, bursts open, shoots the water down the pipe, keeps it all clear before it snaps shut, ready for the next cycle. So it was a really interesting project to be involved in. As I said, the team from Welsh Water that worked on it won the innovation prize for new ideas, and they've been using WaStops for those applications ever since, which has been great to see. So, going to try as smoothly as possible, hand you over to Martin Wiedeberg, who's going to give you a little bit more of the technical insights to the WaStops and things which make the WaStop so unique. So you should have control now, Martin.
Yes, I think you can see my presentation now.
Yep.
Can you see me as well?
We can see you as well, Martin.
Excellent. All right, thank you, Martin.
Sorry, before you start, I'll quickly have a look to see if there's any questions. No sorry.
Question.
I will ask you questions as they pop up, if that's okay, Martin.
Sounds good. Excellent.
Perfect.
All right, everybody. My name is Martin Wiedeberg, and I represent WaPro, which is the manufacturer of the WaStop inline check valve that we're going to talk a little bit more about today. So I thought I would give you a short introduction to the company here, to give an idea of who we are and what we do. And then we're going to jump into the properties of the valve, and I'm also going to showcase a couple of case studies that we've done around the world. So let's give you a short introduction here to the company. WaPro is a Swedish company founded in '88 by a man named Mats Persson. And Mats, he worked as a wastewater civil engineer by profession, and he came in contact with these types of solutions on a quite frequent basis. He also realized that there is actually a lack in the market for high quality non-return valves. So he started to develop his own series of valves. In 2000, Mats developed the WaStop valve. From 2000 up to 2009, WaPro primarily began working in Sweden, but around 2009-2010, WaPro started to expand outside of the Swedish border. Started to work with partners like Aquatic Control Engineering, for example, in the UK, and in other markets as well. Since 2009, we've established a subsidiary in Chicago, where we have our own sales team over in the States as well. And since 2015, we've established branches in Stockholm, we've established branches in Florida, Munich, as well as in the New Jersey and the Carolinas in the States. So let's jump ahead here. We are very proud to say that WaPro is a market-leading provider of high-value flow regulation and protection solutions for both flood, for surface and wastewater, primarily in gravity-fed systems. But as Martin said before, we are able to supply the valve to pump applications as well. Then we're using a bespoke membrane, bespoke fixings. So it's a kind of a different solution there. At our facility here in Karlshamn, Sweden, we design, we source, we assemble, we test, and we sell the solutions based on patented technology. So everything is made in-house by WaPro. We have our own technical support team based here in Karlshamn, as well as the production team. So every valve that we provide to ACE, for example, we test ourselves. We test the opening pressure, like Martin talked about. We test the closing pressure. We're also able to test the back pressure for the different valves. At the moment, WaPro are working with 20-25 countries around the world. And we have around 55,000 installations worldwide for WaStop. I'm not going through all of them today, but I'm going to show you a couple of case studies. So let's jump into the WaStop inline check valve. And I would like to start with a short video here to just show the function of the valve. So as Martin touched upon before, what makes WaStop unique is that the valve requires a certain amount of pressure before the membrane pops open. So WaStop builds up a pressure enough to let the membrane pop open, lets the water out, immediately closes, builds up new pressure, opens, builds up new pressure. So every time the membrane pops open, we ensure a pulsating effect, which minimizes the risk of debris, for example, getting trapped between the membrane and the stainless steel valve. It also ensures that if we have a lot of sand build up and debris build up in front of the valve, that gets flushed away as well. And if we take a look at the membrane here, as you can see, the membrane is conical, and there is a reason for that. If we have a lot of sand and silt build up inside the pipe, what will happen is all the heavier particles will collect itself closer to the bottom of the membrane, and the farther upstream we go, the cleaner the water is. So when it's time for the membrane to pop open, the heavier particles get flushed out first. In terms of construction material, we have two different types of valves. We have the stainless steel version, intended for insertion into pipes, and we also have a plastic series that's intended for online installation. So if we have a pipe section, we can cut the pipe section in half, we insert the valve, the outside diameter of the plastic valve is the same as the specific pipe, and the valve is mounted with flexible couplings, whilst the stainless steel version is for insertion. When it comes to the dimensions, for the stainless steel version, we have the valve both in 304 and 316 steel, in dimensions from DN100 up to DN1800, to suit both standard and also non-standard pipes. For the plastic range, we have a couple of different plastic materials. We have PVC, we have PP, and we have PE, available in DN75 up to 315, depending on what type of situation we are encountering. We can use different material as well. When it comes to the installation of the valve, if we begin with the stainless steel version, if we take a look at the picture here, if we have a head wall, for example, the valve is inserted into the pipe. We have a conical seal that starts off very thin and it gets thicker and thicker. That means that if we have an old pipe, for example, or a plastic concrete pipe, the seal will seal at different points depending on what type of internal diameter we have. So we insert the valve into the pipe. If we have a concrete face, we can just use the existing fixings and bolt the valve in place directly into the concrete. WaStop is also very versatile. So the inlet side is exactly the same as the outlet side. So let's say we have a chamber and we would like to install the valve on the outlet side. We can just remove the fixings and the seal to this end of the valve, and then we can insert the valve from this side and bolt it in place. So it's very, very versatile and very easy to handle. It can be installed both horizontal and vertically. We have a point here, lowest head loss amongst inline check valves. I have a slide later on that I will show you a couple of graphs. But the very idea with this valve is that we are using thin stainless steel housing, which means that we are reducing the internal diameter of the specific pipe as little as possible, in combination with a very flexible memory membrane to enable as much evacuation of water as possible. And these 2 points ensures that we all have a tremendous low head loss for this specific valve. WaStop is also used to stop liquids, gases, odors, and also insects and small animals, depending on the application. So let's have a look at this picture. I think it's pretty clear and it explains very well where we can use this type of valves. And I would like to start by pointing at this specific application here. Emergency overflow pipes from pumping stations. That is a very common application for WaStop. We want to prevent rising sea levels, high river levels, lake levels, entering back into the pumping station, causing either the council or the water company to pump seawater, for example, to the water treatment plants. Not very cost efficient. So that's a very common application. And we can install the valve either directly on the outfall. If we have a chamber between the pump and outfall, we can insert the valve inside the chamber, or even directly inside the pumping station on the outlet side. Another common application is this connecting point here. So we have the black line, which is sewage water, and the gray line is stormwater. In a lot of cities around the world, we do have the ability to overflow the sewage water into the stormwater network to minimize the risk of overloaded sewage networks. But with heavy rainfall, we obviously don't want the rainwater entering back into the sewage network. So that is a very common application for the valve, to let the sewage water out, but stops against the backflow from the stormwater network.
Yeah, just quickly, Martin, I must say in the UK, most are combined sewers in the UK.
Yeah. And to that point, ACE has actually installed quite a lot of valves for private properties for that exact reason. When we have heavy rainfall, in some areas we might have under-dimensioned pipe networks as well, which may cause basement floodings, for example. So this valve is quite common to be installed to protect private properties from basement floodings. In the UK, for example, it's quite common to have a chamber in connection to the main pipe. It's very easy to just insert the valve into the pipe and the problem is solved. In Sweden, it's not very common to have a chamber in connection to the pipe. So in those applications, we can use the plastic range to insert on the lateral service pipe from the property. Another common application for the valve is actually clean water attenuation tanks, drinking water tanks. Because in a lot of places, if we have a low reservoir, they usually have an overflow pipe going into either a stream or a ditch or even a stormwater pipe network. Obviously, we don't want small animals, insects, bad odor to be able to enter into the drinking reservoir, contaminating the water. So that is quite a common application as well, to install the valve on those overflow pipes. And obviously, stormwater outfalls, either into the sea, to the lake, to the river, quite common as well. Here's a couple of pictures of various installation options. If we take a look at the left side here, that's a regular manhole installation. As I mentioned before, the valve can be installed both at the inlet side and the outlet side and bolt into the concrete chamber. If we have a plastic chamber and we don't want to screw the valve in place through the plastic, a very common thing is to just weld a flat plastic plate, insert the valve, and then screw it in place through the plastic plate. So it's very easy. We can also produce valves with elliptical flanges, depending on the application, as well as vertical installations. That is quite common, actually. We supplied, I believe it was 110 valves to Oslo, because in Oslo they had a combined sewage and stormwater culvert. And in dry periods, a bad smell entered up to the pavement. So an easy way to fix this was for the council to install the valve vertical to let the rainwater through, but prevent against the bad odor entering up to the street.
Yeah. ACE has already done some applications in Hull, for example, where we had a row of WaStops vertical underneath a quay, so that the sea could not come back in, but the water could drain on the seawall. And in Cumbria for a similar application to what you're talking about.
Yeah, that's correct. If we don't have a head wall, like we see here on the picture, it's very easy to install the valve. We just insert the valve, and then we use a flexible coupling around the pipe and around the valve to hold it in place. And here in the bottom left, you will see the picture of the plastic range, the PVC valves, to be installed online on the existing pipe with flexible couplings on both ends. So I'm going to show you a short clip here of us testing a DN1200 WaStop to showcase this pulsating flow effect. And what we wanted to showcase here is that even if we don't have tremendous amount of water upstream, the membrane will still be able to build up enough water to flush the pipe clean and flush the debris out from the valve. So we fill it up with everything we can find. One shoe, cans, bottles, towels, everything. Should debris getting trapped between the membrane and the valve, another unique thing with WaStop is, since we're using a very flexible memory membrane, as soon as we have a backflow event pushing against the membrane will go slightly backwards and slightly downwards, ensuring somewhat of a seal against the trapped solid. Enough to build up enough pressure behind the membrane to have this pulsating effect. So to some extent, the WaStop valve is self-cleaning as well. And that is a difference between the WaStop and a flat valve, for example, because if we have debris getting trapped between the flat valve and the pipe, the flat valve will be somewhat pried open. But with the memory membrane and the flexible membrane, we will still ensure somewhat of a seal. All right, let's jump into the head loss. And this is quite interesting because it can be a bit difficult to compare head loss data for different products on the market. One of the reasons why it might be difficult is, let's say a company would make their figures look a little bit better. They might use the reference point to measure the data at the top of the pipe, which will exclude the total diameter of the pipe itself, and they might not include the total exit losses of the pipe outlet. In all of WaPro's data, we use the reference point at the invert level of the pipe, which means that we include the total diameter of the pipe, and we include the exit losses of the pipe outlet. So, to compare WaStop with a competing rubber inline valve, we did a third-party testing at Utah State Water Laboratory to test the different head loss data. And the blue line here is WaStop, and the black line is the competing inline rubber valve. So we use the same reference points, the same testing facility, the same open air scenario. And what we concluded was that at 150 liters per second, WaStop had approximately 1 meter of head loss, whilst the competing rubber valve had 2.9. So WaStop has 65% less head loss than the competing rubber valve. So quite substantial difference there. And the reason for that is, once again, the thin stainless steel material. By using this material, we ensure that we don't restrict the internal pipe diameter more than necessary. WaStop is also certified according to the European standard, CE certified, and the standard range when getting the CE certification for the valve is nominal diameter from 80 millimeter up to 200. So that is just a standard range. But we ensure that all the valves that we produce, whether it's a 200 or 500 or 1800, follows the exact same testing procedure where we test the opening pressure and the closing pressure of the valve, as well as the backflow against the valve. So we have a very rigorous testing procedure here at our production facility. So let's jump into a couple of case studies here. This is in Lomma, Sweden, and this is a stormwater outfall. And the problem here was that every time the sea level was high, a lot of seaweed and sand got flushed up against the outfall, collecting itself inside the pipe, causing the council to spend approximately 7,000 euros per year in maintaining this specific outfall. So the council phoned up WaPro and said, hey, can you help us with this solution? So we had a survey and we had a look at the pipe. We concluded that the pipe is a concrete 800 pipe, which means that we have 800 millimeter internal diameter. So we could use a standard WaStop. To ease the installation for the customer, we also manufacture bespoke fixings to suit a specific outlet. So due to the thin material of the valve, two guys could actually lift the valve up, push it in place, and then bolt it straight into the pipe outlet. The installation took approximately 40 minutes, so it's very easy to handle. This is a case study from Västervik in Sweden. And this is actually a project that I was involved with myself. And the problem in this area were that the council had quite a few overflow pipes from either a pumping station or combined chambers going directly into the sea. And every time the sea level was high, a lot of water was pushed up against these specific overflow pipes. In this specific application, you can see a combined chamber here. So on the left side, we have sewage water. On the right side, we have stormwater. In the middle here, we have an overflow wall. So in case of overloaded sewage networks, the water needs to be able to overflow the wall and entering out. Obviously, we don't want the seawater entering back in, because in this specific area, the council could see a curve like this inside the pumping station every time we have high sea levels, which means that they were pumping seawater to the treatment plant. Very cost inefficient. As you can see in the picture here, we have a bearing beam in the middle, which means that we couldn't really install the valve inside the chamber. So we came up with a different solution. The customer cut the top half of the concrete pipe off. We manufactured a bespoke half flange on the inlet side of the valve to suit the thickness of the pipe. The customer inserted the valve, bolted in directly into the concrete pipe, and put the top section back on and fill it up with sand. And now the customer can access the valve from the chamber. It's approximately 2 meters from the chamber. So should any maintenance be required, it's very easy to access. WaStop protect against rising sea levels and lets the storm or combined water out if needed. So this also showcases the ability we have to do bespoke solutions for our customers. All right, a little comparison between the WaStop and a flat valve. This is a pumping station application in Simrishamn, southern part of Sweden. In this specific area, every time we had high sea levels, a lot of sand was flushed up against the outfall. And since we had a flat valve that was trickling the water out, that means that the sand was collecting itself between the flap and the pipe, actually entered into the pumping station. So the council has spent approximately 8,000 euros per year in maintaining this specific pumping station to clean it from sand. Because a side effect of this was that the properties in the surrounding area got basement floodings every time this happened, because the pumps were insufficient to cope with the amount of sand that was flushed in. So we changed it to a WaStop. And because we have a pulsating flow, not only were we able to clean the pipe both upstream, but we also ensured that the sand in front of the valve got flushed away. Then obviously, if we have sand buildup covering the entire pipe, some type of maintenance will still be required, but we still prevent the sand from entering into the pump because the membrane is always closed. Well, we also have some bespoke solutions for that. So to minimize the maintenance completely, we had a very interesting project in Kerahana Bay, New Zealand. And this is a stormwater outfall. And the client had a big problem with a lot of sand buildup in front of this outfall. So they tried everything. They tried grates, they tried flat valves. Nothing really did the job. So we came up with a solution here. We supplied 2 DN1000 WaStops with a rectangular backplate to fit to the head wall with an overflow pipe. So what happens here is, if we have regular sand buildup to this level here, for example, that means that the pulsating effect of the valve will actually flush it away. But in the worst case scenario here, if the sand buildup reaches up to here, what will happen is that the pressure behind the valves will build up and start to trickle down through the overflow pipe, liquefying the sand in front of the 2 valves, enabling the 2 membranes to pop open. So by utilizing this type of solution, we have now helped the customer to minimize the maintenance from every 3 weeks digging sand to virtually no maintenance at all. And again, this also showcases that we do have the capability to make customized solutions. This is another interesting project I was involved with myself. This is also in Sweden, in Torsås. And this is a stormwater application. And the problem in this region was that this is a new development site in connection to a big river. And every time we have high river levels, a lot of water was flushed up against the stormwater outfalls, flooding the streets in this new development site. So we had a look at the specific outfall here, and the client mentioned to me that, hey, we would like to install a valve inside the concrete manhole upstream the outfall, because we don't have any head wall to mount the valve, we only have a corrugated plastic pipe. So we need to install the valve inside the manhole. Well, wait a minute. So we had a look at the outfall, and we concluded that the outfall was actually a corrugated plastic pipe. So we came up with a solution for the customer. We supplied a standard 800 WaStop where we manufactured bespoke fixings with 90-degree bends. So the customer could actually just insert the valve into the plastic pipe and screw it in place through the plastic, and then seal the remaining gap between the pipe and the valve with a sealant, for example. And by utilizing this type of installation, we saved the council tremendous amounts of money, because should they install the valve in the manhole, they would need to have an excavator, they would need to make civil construction work inside the manhole to fit the valve. But this installation took them 35 minutes, so they were extremely happy with the result here. Early on in the presentation, I mentioned that WaStop is quite common on water reservoirs as well. And this is a project in Svenljunga, Sweden. And in Svenljunga, they had 19 low water reservoirs. And every reservoir had an overflow pipe going either into a ditch or stream with no protection. The municipality haven't had any problems as of yet, but they realized that, hey, if we don't have any protection, it's quite easy for small animals, insects, bad odor to enter into the drinking reservoir and contaminate the water, which wouldn't be the best thing. So we supplied a valve for every water reservoir to fit on the emergency overflow pipes. So since we don't have any head walls, we remove the fixings, we insert the valve, and the valve is mounted with a flexible coupling. And if you take a look at the picture here, in front of the valve we have a thin stainless steel flap as well. And the reason for the flap is that the council was a bit worried about perhaps having rats or rodents kind of entering into the membrane. So we supplied the thin stainless steel flap as an extra protection. We can't, however, say that the flap is rat protected, but still, it gave the council a bit more reassurance that the valve is protected. This is a project in Norrköping, Sweden, and this is 2 emergency overflow pipes from pumping stations. And the problem here was that upstream these 2 outfalls, we have an industrial area with a lot of buildings. And every time we had high sea levels, a lot of water was flushed up against the outfall, entering into the pumping stations, causing the municipality to pump seawater to the treatment plants, as well as actually overflowing into the basements in the surrounding area. So the council, they started to build a levee to withstand rising sea levels, but they still needed some type of protection on the outfall pipes. So we supplied 2 standard 800 WaStops, and as you can see, the installation is quite easy. Again, insert the valve, we have a rubber sealing to seal against the inside of the concrete pipe, and then we can just use the standard fixings to bolt the valve in place directly into the pipe. So the valve is very easy to handle. When it comes to the technical documentation and drawings, you will find both the drawings for all the dimensions and the technical specifications on both WaPro's own website, but also on ACE's website, where you can download the drawings in both PDF, you can download the DVG files, step files, whatever you need. I don't think that you can see the data very well here, but depending on the size of the valve, we have 3 different membranes to choose from. We have one soft membrane to withstand 3 meter back pressure. We have one standard membrane to withstand 5 meter back pressure. And then we have one hard membrane to withstand 8 meter back pressure. When should we use the soft membrane compared to the standard membrane, for example? Well, let's say we have a private property with a very flat service pipe. Then we might not have the ability to build up enough pressure behind the valve to actually have the membrane open. Then the soft membrane can be an option, because the soft membrane requires less water to open. So the membrane will actually open a little bit quicker, flushing the pipe clean. So that is one option. If we, for example, have a tidal application, where we know for a fact that the most critical tidal event could reach 6 or 7 meters perhaps, obviously the hard membrane is the one to use. At the technical specification, you will also find the horizontal differential pressure as well as the submerged opening pressure. Because when the valve is submerged underwater, the membrane will actually have a floating effect. So it will open a little bit quicker than above water. But then again, we are working with differential pressure. So if we have a meter of water in front of the valve, we need 1 meter of water plus the submerged opening pressure to enable the membrane to pop open. You will also find the head loss data on every valve, every dimension on the technical specifications as well, both in the open air scenario, the submerged, and we have also included the head loss data for the specific pipe to which the valve is to be installed in. All right, that was all I got for today. I thank you for your participation in this webinar, and I will leave it up to Martin to end the presentation here. So thank you. Thank
you, Martin. If you could put the presenter back to me.
Yes.
That would be great. Thank you. Can you see the screen?
No.
No. Ooh. I'll stop sharing and try and share again. Is it working this time?
I can't see the presentation.
Yeah, unfortunately that hasn't gone as smooth as possible. But what I was just going to add to the end of what Martin was saying, I had a couple of slides just to show, please do visit our website. If you want the technical details, we have it all on there. We also, of course, are the stockist for not just WaStops, but also penstocks and flat valves. So penstocks and flat valves up to 1 meter, WaStops up to 600 mil, we can do next day. We can also offer full installation and project management. So particularly for the larger WaStops, our customers value the fact that we can come, install it, and then you've got the original manufacturers, the OEM UK distributor installing the kit, so we can issue according warranties with things like that. Yeah, it's a shame because my next slide was to show our other partners. So of course, KWT, Landustry for the weed screen cleaners, Pentair for the fish-friendly axial flow pumps, Fish Flow for the Archimedean screw pumps, Janssen Venable for the large steel constructions, lock gates, big stop logs, things like that. Of course, this is a series of webinars that we're going to be doing. So the next one is likely to be on fish-friendly pumps, both axial flow and Archimedean screws. So I'm looking forward to updating everyone with dates for that. Please join us if you're interested, but watch this space. There's going to be more on flow control again, on weed screen cleaners, whole turnkey pumping stations, all sorts of interesting projects and solutions that ACE have to offer. Our email address is info@aquaticcontrol.co.uk. You can phone us on 01777 249 080. And we hope to hear from you all. I hope you all got something out of this. If you'd like to email with any feedback, please do. And thank you for your time today. And thanks to you, Martin.
Thank you, Martin. Have a good day.
You too. Goodbye.
Goodbye.